All right, welcome back to Unit 4 on probability, random variables, and probability distributions. In this video, we're going to cover topic 4.8, mean and standard deviation of random variables. All right, so let's quickly revisit the law of large numbers. And by the end of this video, I hope you realize why. Recall the law of large numbers tells us that the true relative frequency, otherwise known as probability, of an event will only be seen in the long run after a large number of trials. You know, the easy way to understand the law of large numbers is flipping a coin. We all know the probability of getting a head is 50%, but that's not going to be true in 10 tosses. That's not going to be true in 20 tosses. The only time we're truly going to see 50% head is after a large number of trials. And the same concept applies to means as well. As a mean is nothing more than a relative frequency, right? That's all a mean is you add up how many times something's occurred and then you divide it by how many times it's done, right? So finding a mean is the idea of what a mean is has an actual lot to do with the law of large numbers. And I really want to make sure that you understand that. So let's think about LeBron James for a second. Let's let the random variable P be the number of points he scores in a game. It's random, right? How many points is LeBron going to score tonight? I don't know exactly what the answer is, but that's the idea, right? It's a numerical outcome that I don't know, hence it's a random variable. So let's just say I said, hey, let's find the mean number of points LeBron scores in 5 games. Well, everybody knows how to do that. You simply take the points he gets over the course of 5 games. So that's what I actually went ahead and did here. So he scored 21, 18, 24, 29, and 32 points. I added them together to get 124, and then I divided by 5 to get his mean. Now, this is an X bar. This is a mean of a sample of 5 games. Now, this is called a statistic, right? Remember, statistics are anything that come from a sample. So it's called a statistic because it came from a sample, S&S. All right, but you know, what's his true mean? What is the true mean? Well, LeBron's true average points per game could only be found after a large number of games, kind of like the law of large numbers, right? And this symbol I'm going to use is mu, because this is a parameter, right? You know, LeBron has played thousands of games in his career at this point. So 27.1 points per game is his average after a large number of games. That's not just from a sample, that's from a large number of games. Now, I know that realistically you can look it up and you can find out exactly how many games LeBron has played to date. But at the same time, this is just a concept I'm trying to get across to you, is that a statistic is something from a small sample, like just 5 games. That's a mean that everybody knows how to find. But a true population mean would be the mean over all of his games, a large number of games. And for LeBron at this point, that's 27.1 points per game. So there's a difference between just saying, oh, you know, the last 5 games, LeBron has averaged 24.8 points per game, whereas his career average, right, is from a large number of games. So this is called a parameter because it comes from all of his games, not just the last 5, all of his games. So that's the difference between X bar and mu. And the law of large numbers fits in here because the true mean of all of his games is only found after a large number of games. Another situation you could look at this is like a rookie, like a brand new player. Well, after that brand new player plays 5 games in the NBA, that is by no means his true mean. That's just the mean after his first 5 games. The more games that player plays, the more ups and downs that player has after a large number of games, only then can we sit back and say, hey, his true mean was, whatever it is, okay? So a true mean is found after a long repetition of the random variable. So what is a mean of a random variable, right? First off, this is also known as an expected value, and I'll try to explain that in a moment. But the mean of a random variable is simply the average value of that random variable if it were repeated a large number of times. So keep that in mind. A mean of a random variable is not found after doing it 5 times. It's not found after doing it 10 times. It's found after doing it a large number of times, just like probability. Now, a mean is also known as an expected value. I mean, think about that. The mean of any variable is simply what we expect that variable to be, just like LeBron's mean. LeBron's mean is how many points we expect him to score on any given night. But of course, that expected value will vary. So there's also going to be a standard deviation with that. But like, I hope that that idea of why we call a mean an expected value makes a lot of sense. So if you say, hey, LeBron's playing in a basketball game tonight. Well, okay. I know after literally all of his games, he averages 27.1 points. So I expect him to score 27.1 points tonight. Now, first, that is actually impossible. There's no way you could score 27.1 points in a basketball game. You could score 27, you could score 28, but nobody has ever scored 27.1 points in one game. But again, it's an average. That's the idea, is the mean is an average over a large number of games. So that is why tonight I expect him to score 27.1, but I know that that number is going to vary. He could score more. He could score less. There's going to be a standard deviation at play as well. And if you know anything about LeBron, he scores a lot of points pretty consistently. So LeBron's actually going to have a very low standard deviation. Most nights he will score something very, very close to his mean. Because remember, that's what standard deviation is, how far you are from the mean on any typical game for LeBron. All right, so let's kind of make sure we understand this. And I'll put LeBron aside for a second. Can we understand this with a different example? So here's an example that we've seen in our last video where Q represents the number of employees who work at a certain restaurant on a given day. The following table shows the probability distribution for Q. So, at a random day at this restaurant, there could be 20, 21, 22, 23, or 24 employees, and the probabilities are listed here as well. So what would the mean or the expected amount of employees at work on any given day represent? Well, first off, how would I actually find the mean? So please keep in mind the definition. The mean is the relative frequency in the long run. So if I were to actually want to find the mean, I would have to sit and just watch the restaurant. On day one, how many people are working? Oh, 22. On day two, how many people are working? Oh, 24. And day three, how many people are working? Oh, 22 again. Oh, how many people are working on the next day? 23. And I would literally just keep track, keep a long running list of how many employees are there on many, many, many days. And then after I have this long list, I could add everything together and divide by how many numbers are on the list, and I would get the mean. Well, that's exactly what the mean is. The mean number for employees would be how many employees we would expect per day after looking at a large number of days, right? A mean is not found after looking at 5 days. Again, it's just like probability. The true mean is only found after looking at a large number of days. So yes, I understand that most days there's going to be 23 or 24 employees, but some days there's going to be 20, 21, 22 as well. I mean, it does happen 10% of the time, but after looking at many, many, many days, we would expect there to be the mean amount of employees on any given day. So please make sure you understand how to explain what the mean is. Now, the question I hope you're wondering in your head is, how the heck do I find it? Well, again, simulation-wise, experimental-wise, what I would do is I would literally just sit here and every day I would record how many employees were at work, and I would just do this over and over and over again. And maybe after 1,000 days, I would add up all the different numbers I have, 20, 21, 22, 23, 24, and divide by 1,000, I would get my mean. But even that's not going to get me the exact answer, because remember, the definition says the true mean can only be found after a large number, and 1,000 is technically not a large. So how do I actually find the mean? Well, believe it or not, there's a very simple formula. Here it is. This is a formula to find the mean or expected value of a discrete random variable. All right, so we got to understand a lot here. First, we got to understand this symbol. Notice here, this is a mean of all, a large number. This is not a mean of a sample. This is a mean of a large number of trials, a large number of days. So I'm going to be using this symbol mu because it's a parameter, right? This is true for the entire population of days, not just a sample. So notice I'm using mu, not X bar. And the other thing we do is we put a little subscript here for the random variable. So when we go back and find the actual mean for the number of days, that would be the mean for Q. So you just, whatever random variable you're working with, you put as like a little subscript. Okay, now how do you actually find the mean? Well, it's actually quite simple. What you do is this first symbol right here, this weird looking E, is the sum. So what you do is you take the sum of each outcome multiplied by its probability. So you take each outcome times its probability, and then you add them all together. It's really that easy. And again, these I's are just representing the individual outcomes. So you take, the first outcome times the first probability, plus the second outcome times the second probability, plus the third outcome times the third probability. And you just repeat for every single outcome multiplied by its probability. So it's a really easy formula. It's very, very simple to use, but please understand the symbol we use to represent the mean and make sure you understand how to use it. It's really, really simple. If you're still a little bit confused by the symbols, once we do an example, I think you'll find it very easy. But I'm going to tell you this right now. I will never ask you to find a mean without also asking you to interpret. So please make sure you know how to describe what the mean is. And again, I would start off by saying, if we were to repeat this random variable a large number of times, this is what we would expect, because that's what the mean is. Now, you will also never have a mean without a standard deviation, because just like LeBron, we expect him to score 27.1 points per game, but it could be a little more, could be a little less. So here is the formula for standard deviation. Definitely an uglier formula, but I'm going to give you some good news in a couple moments here. First, notice the symbol for standard deviation. This is not S, right? That's the standard deviation of a sample. No. We use sigma. That's the standard deviation of a population, because we're not just looking at 10 days, we're looking at all days. And again, we use the subscript for the random variable. So we're going to be finding the standard deviation of Q. So it just is a way to personalize it to your problem using the letter from your random variable. Now this form is a little bit uglier to use, but let me explain real quick. All right, what you do is you take each outcome minus the mean. And I kind of, didn't write that very well here. Actually, I could kind of need to redo this. Let me see this. So what you do is you take each outcome, each individual outcome, and you subtract the mean. So what you're doing is you're finding out how far each outcome is from the mean. You're going to square that value and then multiply by its probability. Okay, that's a little bit more of a process, but I'll repeat that. You take each outcome minus the mean that you found earlier, square that value, multiply by its probability, and then you add all of those together. So you do it for the first outcome. Take the first outcome minus the mean, square it, times it by the first probability, repeat. Now, if you forget the square root, the number inside the square root is called the variance. Okay? Think of variance as simply like a step along the way to get standard deviation. Once you take the square root of the variance, you get the standard deviation. Now, once again, I'm never, ever going to ask you to find standard deviation without asking you to interpret it. So remember, the standard deviation is how far any particular outcome will vary from the mean. So I can just kind of give you a quick example here, right? If LeBron's average is 27.1 points and his standard deviation was 2.3 points, this means that after a large number of games, LeBron is expected to score 27.1 points per game. But that actual score will deviate by 2.3 points from the mean. So he could easily be 2.3 points higher, or he could easily be 2.3 points lower. And again, that's a small standard deviation. That's because LeBron is pretty consistent in scoring a lot of points. All right, I will say that this formula for standard deviation is a little bit more complicated, but just give me a couple moments. I am going to teach you in this video how you could use your calculator to do all of the work for you. All right, so let's do it by hand first, because then if you do it by hand, you'll at least appreciate the process. All right, so here's back to the example of how many people are at work on a given day at this restaurant. So we have the employees and we have their probabilities. So let's find the mean and let's find the standard deviation. Now, finding the mean is actually quite easy to do by hand. All you got to do to find the mean for Q is take the outcome times its probability, and then you got to add it to the next outcome times its probability, and then add it to the next outcome times its probability, and then add it to the next outcome times its probability. It is a little bit repetitive, but repetitive is not a bad thing. Times the next outcome times its probability. And then multiply and add. You could type all that into your calculator at one time. Now, to get the standard deviation is a little bit confusing. You do have to get the mean first. So actually, on the next slide, I'm going to show you the work. All right, right here is the mean for Q that I did, each outcome times its probability, and I got a mean of 22.7 employees. What that means is after we were to examine a large number of days, we would expect 22.7 employees to be there on any given day. Now, somebody might say, wait a minute, Mr. Princhak, you can't have 22.7 employees. That's impossible on any given day. Yes, I know that. But remember, just like LeBron, this is a mean. This is the average of many days. So the average after many days would be 22.7 employees. So again, think about if I were to sit and keep track of how many employees were working after 2,000 days, and then I would divide, this is something very close to what I expect the mean to be. Now what about the standard deviation? Well, again, a much uglier formula, but let me walk you through what I did here. You take the first outcome minus the mean of 22.7, square that, multiply by its probability. So again, let me kind of put that into brackets. So each outcome minus the mean squared times its probability. And then you repeat. 21 minus the mean squared times its probability. 22 minus the mean squared times its probability. 23 minus the mean squared times its probability. 24 minus the mean squared times its probability. And after you do all that, you get 1.27 employees. So now that I found these values, I'm telling you right now, I'm never going to ask for those numbers alone without asking you to interpret. So what do these two numbers mean? Well, if we were to examine a large number of days, the mean number of employees per day would be 22.7 employees. Now, on average, the number of employees per day would vary by 1.27 from the mean. So again, the mean is saying what you expect to happen. The standard deviation is saying, hey, it could be a little higher, it could be a little bit lower. So the mean is pretty easy to understand. Standard deviation is a little bit tricky, but again, you're saying, hey, listen, I know that I'm supposed to expect 22.7 employees on any given day as the mean, but on average, the number could vary by 1.27 from the mean. So that's 1.27 higher to 1.27 lower. All right, now what I want to show you guys is how you could get these two numbers, the mean and standard deviation, on your calculator. Because, to be honest, AP Statistics is really more about the interpretation. It's really not so focused on having some tricky math formula, right? Most of the time, you could use your calculator to get the answers you need. The hard part is the interpreting. So I now want to walk you through how to use your calculator. All right, to get the calculator to give you the numbers you need, you have to follow three pretty basic steps. Number one, enter the outcomes into list one. So you're going to hit second stat on your calculator. You're going to list all of the outcomes in list one, 20, 21, 22, 23, 24. Then you're going to move to list two. And in list two, you're going to put the probabilities. Now, it's super important that each probability is next to each outcome. So I need the 0.1 to be directly next to the 20, and 0.1 for 21, and 0.1 for 22, and 0.4 for 23, and 0.3 for 24. They do have to correspond. After that's done, you can hit second mode and quit back out and get to the home screen. Then what you're going to do is you're going to hit second, or I'm sorry, not going to hit second. You're going to hit stat, then slide over to calc, and then you're going to select one variable stats. So when you hit the stat button, it starts off on edit. So you're going to slide over to the calc command. Then you're going to grab the very first command, one variable stats, and this is going to pop up on your screen. Now I'm going to tell you right now, if this does not pop on your screen, it's because your stat wizard is turned off. So then you would go to mode and make sure your stat wizard is turned on. But I'm just going to assume everybody knows that and has their stat wizards turned on. All right, so once this screen pops up, next to lists, you want to put list one. That is your outcomes. And then under frequency list, you need to put the probabilities, which is list two. So outcomes go under list, frequency lists are the probabilities. Please, that is super, super important. Then hit calculate and you'll get everything you need. Now, the only thing I hate about your calculator is that it says X bar. And in this situation, it's not an X bar, it is a mu. It is a mean of many trials, not just 10 or 12 or anything like that. Now, the calculator doesn't know the difference, so please make sure that you use the proper symbol, but the 22.7 is the correct number that you need. Then down below a little bit, you will see the proper number here. So I am happy that the calculator does use the proper symbol for standard deviation. The standard deviation sigma is 1.27. So now you don't even have to worry about those formulas as much as I went over those formulas. Trust me, you'll never literally need them. You just need to use your calculator, and it's really, really simple. So please practice doing that, and we'll get some examples later on in this video for you to practice. All right, so pretty simple process, but it will get you the two numbers you need. But please make sure you know how to interpret, and please make sure you use proper notation. All right, the last thing I want to leave you with before we look at some examples is parameters, right? The mean and standard deviation of a random variable are known as parameters. They do not come from a sample. They are the theoretical idea of what the mean and standard deviation would be after a large number of trials, which we could look at as the population. So the idea is that statistics come from samples. We're not talking about a sample of 10 days or 20 days, or in LeBron's case, 5 games. We're talking about a large number. And that could be viewed as the population, which is why these numbers are parameters. They both must be interpreted using correct units and in context to the specific situation that they are coming from. So again, I'm never going to just simply say, what's the mean? What's the standard deviation? I mean, maybe on a multiple choice, but on a show your work question, I'm also going to say, interpret what they mean in context. So please make sure we practice doing that as well. All right, that's it for this video, but the second video for this does cover a bunch of really, really, really good examples. So please do not stop now. Go to the next video and watch examples for topic 4.8.